Hi everyone, this is Ed the Audio Nut and Radio Amateur W8EDW. I normally use this 43-foot ground-mounted antenna and it works really well. I use it in conjunction with a coupler that I have, antenna coupler that I have in the shed. And works well on 80 and 40, 20. Doesn't work well on 10. So I decided to make a 10-meter antenna, but I wanted to be able to remotely switch it from my vertical to the 10-meter antenna. So I designed this antenna switch. It's going to be able to be remotely switched from my shack that's in the basement. So here's the components that I'm going to use to do that. So the first thing we needed was a box. This is an electrical box. It's just a junction box that you can get at Home Depot or Lowe's or any of those places. But I got mine on online. I went ahead and ordered it. It was like $17 or so. But this is the model number on it. I'll bring it in slowly. Hopefully this thing will focus and we can get the number on there for you. It is a JB 3955 is the model number there. And that's the important thing. It's made by Bud, B-U-D. So anyway, that's the box. So the next item was a 12-volt relay, and I picked one that is actually a double pole, double throw contact relay. High power, which is nice. Has some really good components in there. And I'm probably going to wire the contacts in parallel so that way it has less resistance. But I think I paid around $15-20 for this on Amazon. The model number is, I don't know if you guys can read this, if that darn thing will focus, but that's it right there. It's made by Maine, and it's a 12-volt double pole, double throw relay. So that's that item. Next thing we needed was the SO239 antenna connectors, and now these will mount, of course, on the box. I'll need one for input and two for output, so I needed 3 of these. And then again, got it on Amazon. They weren't very expensive. I think there was a deal where you could get 3 of them for like $12. So, not bad. So the next part we needed was a way to get 12 volts into the system, and of course I picked Speak-On, and it's an NL4MP is the model of this. Perfect for carrying 12 volts, and the NL4FC plug will go on the cable. It's going to bring 12 volts to this. But anyway, got it on Amazon, and then again, not very expensive. I think it was $5 for that. So that's the basic components, and next thing is going to be to mount everything onto the box. Inspecting the box, we see that it does have punch outs. The unfortunate thing is none of those punch outs fit any of these components that we need to mount on there. So I'm going to end up using a hole saw. It's going to be a lot closer to the right size we need. The other thing that's kind of cool about this particular box is that it has a real nice heavy duty lid that comes with it, and very heavy duty. It'll make a nice shield for our relay. So the next thing is going to be cutting the holes for the components to fit. I decided I'm going to put the SO239s on this side of the box here. I'll put all 3 of them there. And I marked them evenly across, punched them so that way the drill doesn't skate around on them. And I also noticed that the SO239, I used my drill gauge on it, is about a 1/2 inch is all we need on this internal part of the panel mount. And that's what's going to go through the hole. So about a 1/2 inch drill is all I need. And then I might have to touch it up a little bit, maybe with a step bit. So that's what I'm going to do next. So I'm going to drill the pilot holes first, because I think the 1/2 inch is just a little too big to try to take all at once here. So I'm starting this here. Seems to be good. So now I'm going to move, I think that's about a 1/4 inch there. I'm going to move up to the 1/2 inch. Take it slow and see if we can get a nice clean hole. So now I got the bigger boy in there. I got the 1/2 incher, and we'll see how it does. That seemed pretty painless. Okay, and then I just got 2 more holes to do. I'm starting to mount the SO239 panel mounts onto the box. I found that the 1/2 inch drill wasn't quite big enough. It was just a little bit shy of letting that connector sit down into the hole right. So what I did was I used a step bit and reamed it out just slightly. That was all it took. So anyway, the screws I'm using to mount these, I'm using an M3, and it's at 50 by 20. And the nice thing about these is they're long enough, they extend into the box. That way I'll be able to put a nut on the screw and actually hold my ground straps down that way. And I'll get into that when we get into the box and start building the inside. But anyway, starting to come together. I'll show you guys a little trick that I use to square up the connectors and also kind of hold them in place while I'm drilling the holes. Is I lay a piece of tape on the connector to kind of hold it in place like that. And then it doesn't shift around when you're drilling. I can actually take this away, and see, it holds it in place. It doesn't let it shift this way. So that's what I do, and then I think 2 screws on each one is going to be plenty. So I'm going to drill a hole here and have one in that corner, and that's going to be plenty. So before we install it, I wanted to talk about the relay a little bit, and I'm pretty amazed at how nice it's built, you know, for being an inexpensive one. There's a screw right here that you take the top off with. If I can get it to go. There we go. And really well made in here. What I was impressed with was the contacts. They're really nice and big, and both sides, of course, are the same. And the other thing I liked was the contact wire is large, so it's designed to take a lot of power, even on the part that actually flexes. So that's kind of cool. I like that. And looks like it's pretty easy to mount. There's some holes here on each side that that would be good for the screws to just screw it down. But anyway, really, really impressed with it. So what we're going to do now is test it before we install it. I don't want to get it in the box and then discover that it doesn't work that well. So let's do that next. We're ready to test the relay. I hooked up the negative side of the coil over here, and the positive side is over here, this screw right there. So when I touch this onto that, it should close. Let's turn on the power supply. It's a 12-volt power supply, and let's see what happens. Oh yeah, looks like a good solid connection. I like this because it has, look how big those contacts are. So nice and big, not much resistance. And this side's the same. I'm going to put them in parallel so that we've got even less resistance to the antenna signal going through there. So that's good news. It works well, and next thing is going to be now, how are we going to mount this in the box? The relay is mounted in the box and ready to go. I'm going to pre-wire the connectors. That's the project I'm working on next. I'm going to solder the wires onto them. That way when I mount them on the box, all I have to do is connect them up to the relay. So I've got my soldering station out, and I usually prepare my tip of my soldering iron. First of all, you wet this sponge down here, and then what I normally do is hit it with some solder, like that. You kind of get it good and wet, and you wipe it off like this, and get it nice and clean. It gets all the oxidation off, and just makes the heat transfer a lot easier. So that's the setup that I use on my soldering station. So the next thing I got to do is show you how I prepare the wires. I picked out a length of wire I think it's going to be good, running from the connector over to the relay. And normally what I like to do is just strip this off, usually about 1/4 of an inch, maybe a little bit more, and then pre-tin that. So anyway, it's hard to do that on camera, so I'm going to cut away and do that, and then I'll be right back. There's about the length I like to have it stripped off, and then I'm going to tin that. So we're going to tin it. Basically all you do is touch the tip of the soldering iron and the solder together and get it to flow a little bit, and then just drag it across the tip of the wire, and then you have that ready to go. Basically again, just applying the solder to the tip of the iron, letting it flow, and then adding it to the whole joint here, and then just letting it cool. That's all there is to it. So I got to do this 3 more times, and we'll be ready to put the connectors then on the, I'm going to put spade lugs on the other ends of these wires so that they fit under the screws, and just screw them onto the relay. So that'll be what we attack next. I decided to take the relay out of the box to make it simpler to wire up. You can see on the back here, these 2 contacts right here are the ones that go up to the part of the relay that moves. That's going to be our main input. So I'm going to run this wire over here. The center one's going to be our hot from the transmitter, and the wire from that is going to come down and hook to one of these screws here. So that's going to be the main feed into the relay. And then if you notice on the side here, coming up from that is to the part that moves. And you can see that it's setting in the up position when the 12 volts is not engaged. So that's going to be the 43 foot. That way it doesn't have to be on all the time. And rarely will I be using the other antenna, the 10 meter one that I hook on the other output, which will go on this connector or this contact here, so that when the 12 volts is turned on, see how it switches down to that contact right there? And then if you follow that down, that's going to be the output. And that special antenna is going to be on this one. The 43 foot is going to be on this one over here. So that's about it on the relay. So I'm going to start preparing the wires on the connectors here so that I can put spade lugs on them and put them into the screws here and get this thing wired up. You can see I got the panel mounts mounted. The center one here is going to be the one carrying the signal from our transmitter, and then each of the outside connections, this one here is going to be for the 43 foot antenna, and the other one's going to be for probably 10 meter antenna. But let's follow the signal flow a little bit here. The center conductor coming in, follow this wire here to the relay, and then we're just going to follow one side. They're in parallel, but we'll follow one side for the signal flow. Comes up, goes to the part of the relay that switches, and right now it's in the up position because there's no 12 volt present, and then it follows to this contact here, and then if I turn this a little bit, you can see it goes down to this connection, and this connection is the one that connects to this side right here. You can see it's right there, and these two are in parallel. So that's going to be the 43 foot side. Since 12 volts isn't present, that's going to be the normal position all the time. Then when we engage 12 volts, this thing drops down. So let's follow the signal again. Comes into the center conductor, to the relay, up to the part that switches, and this time it's down. It's going to go to this contact right here. From there it goes in parallel again, and you'll notice it comes over to this side of the connector, this one on the right, and that's going to be the one for the probably 10 meter antenna. So that's the flow going through it. The only thing we have to hook up now is the actual 12 volt connection. That'll be the next thing we do. I got the speak-on installed. I used one of the punch outs, and then I just had to ream it out a tiny bit to get it to fit in there. I hooked 2 wires up to it. I'm using +1, ± to carry the 12 volts. And these are going to hook. There's a screw on each side of the relay right here. It's the 12 volts. So we're getting real close here then to putting it back together, and we're going to test it out. All the wiring is complete. The relay fit into the box pretty nicely, really. And there's just one last thing I want to do. Even though these connectors are actually grounded to the metal box, I think it'd be better if I put some ground straps between the ground side of these connectors. That way I'm assured that I have a good clean ground on those. So I'm going to work on making those straps and mounting those. I'm going to make up 2 of the ground straps. Just rolled one end of the strap, stuck it into the terminal, crimped it down, and then what I'll do is do the same thing on the other end. And we'll have 2 straps to bridge between SO259s that are in the box, and make sure our grounds are really good and solid. So ground straps are in, and I just used a nut to put on the same screw that was coming through to put the terminal on, and then I just bridged, between each connector. That way we make sure it's a good ground. And so now I think we're at the testing stage. We're going to test it before I put the cover on it. All right, we're ready to test it. Make sure the relay kicks when we kick on the power supply. Put the speak on in and turn on the supply. Oh wow, good solid snap on the relay, and it looks good to me. So now the question is going to be, is RF going to go through this? So I'm going to put it in line with the COAX out at the shed where the feed point is, and see if we get a signal through it. Here's the setup in the shed, which on the outside wall here is my 43-foot vertical. But basically the LMR 400 coax comes out of this conduit down here and feeds the tuner that is right here. It's the SGC 235 antenna coupler, they call it. And basically it has its own coax that comes out. It's the skinny coax. It's probably like RG58, something like that. And then on the other side of the tuner is the hot wire that feeds my 43-foot vertical. It just goes through the wall there. But basically, I coupled the small coax coming out of the tuner to my LMR 400 down here. So basically what I'm going to do is disconnect that coupling and insert the box right there. And since it's not going to be engaged with 12 volts at this time, I'm at least going to be able to test it and see if a signal will go through it and feed my SGC 235 antenna coupler. So that's going to be the test. So it'll take me a minute here to hook that up. I took out this coupler that I was using to join the coax between the tuner and the LMR 400. I removed that, and then now the box is in the place of that. And you can see I've got the LMR 400 in this connection here in the middle, and then our 43-foot antenna is being fed from the output over here, and that's going to the tuner. So I'm going to run back inside and we're going to fire it up and see if we get a signal. Well, we're going to check and see if it will tune up. Right now I'm in the sideband mode on my radio. Check and make sure the frequency isn't in use. Is the frequency in use, please? Is the frequency in use, please? This is W8 EDW. I'll be testing. So then I'm going to put my radio in the ready mode, so that way I can get a dead carrier. And I'm going to swing back to the meter and then see when I key it if it will tune up. Wow. Goes right in tune right away. Awesome. Now that was on 175. Let me try maybe another frequency. I'll go up to like 275. Try that one. You switch back to sideband mode. Is this frequency in use, please? Is this frequency in use, please? This is W8EDW. I'll be doing some testing. I'm going to go back to remote again. And we'll take a look here. See if it tuned up on that frequency. Yep, no problem. So what you're watching is my SGC 235 antenna coupler out at the base of the antenna, doing its thing, getting it tuned, and we're going through the switch. So obviously the switch does not seem to be hurting it at all. So that's a good thing. All right, and we'll try to make a contact. Let me see if I'm in record here. Just 1 second. Okay, yeah, I got it set up then. Appreciate it, Ron. So I'll let you give me a signal report. And like I said, this is to test out a switch that I built so that I could switch my antenna at the feed point remotely. So KB9JJF, Ron up in Wisconsin. This is W8EDW. Go ahead.
Alrighty, Ed. W8EDW. You are about a 510 to 515 right now on my. From earlier, it has dropped down a little bit, but you get a beautiful, clear signal coming into Wisconsin this afternoon.
All right, we really appreciate the report, Ron, that's for sure. Here, let me cut my recorder off, and we can carry on. I'll be right with you.
All righty.
Well, that wraps up our build on the remote switch box. I think it turned out pretty good. And we are going to continue on with that. I'm going to build a antenna to put on the other side of the switch box besides the 43 footer. So really enjoyed it, and it's always fun to build your own stuff. Makes ham radio fun. I know there's commercially available remote switches, but I thought it'd be more fun just to build our own. So you have to let me know how you liked the video. If you liked it, give me a thumbs up. If you can, also, please subscribe. You guys have a great day, and I'll see you on the next video.